All right, let's take a look at number 4. Write the chemical, balanced formula, chemical equation for each of the following reactions. Now, ammonium chloride, I know that ammonium is NH4, chloride, positive 1, negative 1 charge, so I just need one of each. Calcium hydroxide, I know that, OH is a -1, so I'm going to need 2 of those to balance out the calcium. Reaction arrow, calcium, again, calcium's a +2, so I'm going to need 2 chlorides to balance that out. I got ammonia, which is not a polyatomic ion, okay? It's neutral charge overall, it's ammonia, and so you're not going to see it on your polyatomic ion, but it is NH3, and water. But since we are trying to write a chemical equation, we need to balance this up. Now, we don't really have a whole bunch of polyatomic ions that we can balance on both sides of the reaction arrow, so we're going to have to go atom by atom. Let's start with nitrogen. I have one over here, one over here. That's fine. Move on to the next one. Let's skip hydrogen just because typically it's like more for last. Let's go chlorine. Got 1 on this side, 2 on that side. So I'm going to start by doubling this up to make the chlorines equal. But now since I've doubled this up, I have twice as many nitrogens as I did. So I'm going to put a 2 in front of this ammonia to equal to have the number of nitrogens equal. Next up, we have, let's see, let's just go hydrogens. So for 8 hydrogens right here, 2 more for a total of 10 hydrogens on the reactant side. Moving over here, 2 times 6, 8 right here total. Well, I'm 2 short, so I'm going to put a 2 in front of that to bring this to 10. Okay, so now I move on to oxygen. Oxygen, I have 2 over here and 2 over here. So I am good to go. Moving on to B. Hexane plus oxygen reacts to form carbon dioxide and water. By the way, hexane is C6H14. So we are going to go C6H14 plus O2. Remember, oxygen is a diatomic molecule. Carbon dioxide and water. All right, so we're going for the chemical equation, so we need a balance. Carbons over here, I got 6. Over here, I only got 1. I'm going to put a 6 coefficient right there, so the carbons are equal. Moving on to, I don't know, let's go to hydrogen. Why not? Hydrogen got 14 over here, 2 over here. I can make that equal by putting a 7 right there. Cool beans. Now for oxygens, I have a total of 12 oxygens plus 7 more. That's 19 oxygens, but I got O2. To have 19 oxygens on the product side, I can increase the number of oxygens here, but I'm going to be increasing O2s. You can't multiply O2 by something and have it come out to be 19 oxygens. You'd think, oh, what if I just went 9.5? But remember, we have to have whole number ratios here. That's not a whole number. But here's the thing. If you were to go through and you were to calculate how many atoms of each element you would have on both sides of the reaction arrow based on these coefficients, even though that's a decimal, you'd come out, you'd find that they were perfectly balanced. You'd have the same number on each side. You would have 19 oxygens on that side, 19 oxygens on that side. You'd have 14 hydrogens on that side, 14 hydrogens on that side. You have 6 carbons on this side, 6 carbons on that side. But that's not a whole number. And there's actually a very simple trick to this. You simply double every number. So at the end of the day, you're going to have 2 right there. Let me get out something that I apparently don't have available. So this is going to be a 2. That's not going to be a 9.5. We're going to double that. So it's going to be a 19. I'm going to double that. So that's a 12. I'm going to double this 7 so that it's a 14. And my coefficients are going to be 2, 19, 12, 14.